So as a follow-up to this NSX on UCS video series, I just want to show you how you can leverage Cisco ACI as the underlying network fabric to support an NSX architecture. So when we look at NSX and what it brings to the data center, the key features that I am most interested in are network virtualization. Here's where we deploy virtual routing instances. We perform routing with VXLAN. Also, layer 3 routing in the hypervisor of each ESX host. The benefit here is that inner subnet routing does not have to leave the ESX host for a virtual machine default gateway. Also, in-kernel stateful firewall and microsegmentation security. So we have traffic between virtual machines, which go through a distributed firewall, which is in-kernel. Even before that packet hits that VNIC, resulting in true microsegmentation, right? Which is a huge bonus of NSX. But then we also have integrated services such as load balancing and layer 2 VPN, and these are add-on bonuses, right? So load balancing is especially useful when you don't need that advanced ADC, that application delivery controller feature, right? Also, integration with automation and orchestration tools. We can leverage VRA and VRO for full deployment. Now, although not required, right, VMware advocates for a low latency leaf-spine network architecture, which is used as the transport for NSX. And since we're already introducing network virtualization, right, through that VMware virtualization layer, why do we stop there? Why don't we just continue and bring it to the network fabric, right? And there's a common misconception that it's either all VMware NSX or all Cisco ACI, and you have to pick one or the other for your SDDC strategy. And this is just not true. Both platforms can work together to accomplish one common goal. And that common goal is data center application security. So from a CDI standpoint, I'm here to unite those VMware NSX Democrats with the Cisco ACI Republicans to make that data center great again. But all jokes aside, Cisco can be very beneficial here for NSX. Well, what can it provide? Well, it can provide the underlay network where NSX needs to ride on and provide that IP connectivity, leveraging endpoint groups and bridge domains. It could also simplify the VLAN deployment across all top-of-rack switches, also known as leaf nodes, right, to support the NSX environment. And this simplifies the deployment of the edge, for example, as you can configure VLAN-backed port groups for the edge uplinks, and you could simplify how it's all deployed. It'll also provide that multi-tenancy architecture where you can group separate NSX domains, storage networks, and even network layers such as Internet Edge and DMZ, for example. ACI can also provide that whitelist security for these NSX infrastructure VLANs, being able to secure the ESX management, vMotion, IP storage, VXLAN transport, edge VLANs. And it could also ACI could also manage these infrastructure VLANs with the Cisco ACI managed VDS, so that the NSX domain is more easily and programmatically deployed. ACI also provides security for bare metal and non-virtualized platforms, which may require communication between the NSX network, right? It could also provide that capability of routing over VPC, right? There's some limitation with certain platforms that you deploy. So ACI supports routing over VPC, specifically over on NSX edge deployments. And ACI can provide VMware that recommended leaf-spine, architecture, leveraging that Anycast default gateway on every leaf switch for the NSX transport VLANs. And again, this transport VLANs, what I'm mentioning, it's not to be confused with actually the networks within NSX serving the virtual machines, the actual VXLAN networks that are actually managed by NSX. So that's actually the the infrastructure VLANs that NSX requires. And lastly, it can provide that physical fabric management and the troubleshooting tools, so you can find out if ACI fabric is possibly dropping traffic and where. So, you know, there's really no good reason why you should not integrate VMware NSX with Cisco ACI, right? And I'm going to show you how we can take our existing NSX architecture or NSX deployment that we already put together, and I'll show you what that looks like on top of Cisco ACI. So let's jump into it. All right, so I'm just going to log in here and show you what that configuration looks like that is needed to support NSX. Starting off with the fabric. Under access policies, I usually start off by configuring an attachable access entity profile. So in this case, what I'm doing is I'm connecting the fabric interconnects into the ACI fabric. Each fabric interconnect is going to have its own virtual port channel. So the AEP here for that physical connectivity is right here, referencing a physical domain. So I have UCS FIA and FIB, and they are using the VLAN pool which I created a UCS FIAB pool. And it's a dynamic pool because if it's dynamic, I can later set it to static as needed. So I set it as a dynamic, but I'm actually allocating these VLANs statically. So we have the VLAN 100 for management, VLAN 110 for the motion. We have VLAN 120 for the DMZ, VLAN 200 for VXLAN, and for the edge gateways we have VLAN 300 and 301. So this VLAN pool is associated to both of the physical domains where it connects to the respective FIA or FIB. What I also did was, because I'm going to be creating pretty much one routing process, I created an external routing domain, and I put both of the FIA and FIB into that external router domain. In addition, I'm including there's an ASA cluster that's performing the Internet Edge firewall functionality. I'm adding that as well because I want it to be part of the same routing process, and I'll show you that in a couple seconds. So my global policies are set, are the interface policies. So the policy group here, for example, I would create a VPC policy group for FIA and also for FIB. They both are pretty much the same. I am connecting into the ACI fabric at 1 gig, but typically you would connect at 10 gig. So we have the CDP policy off, LDP policy on, LACP active for the port channel, and then here's my AAEP that I configured earlier. Same configuration for FIB. Then I create an interface profile, and I have 2 interface profiles for each respective fabric interconnect. And what this is just basically telling me is that what it's tying is the actual ports that I'm going to be using in that interface profile. So FIA is connecting to port 147 on each of the leaf switches, and FIB is connecting to port 148. So I take these 2 different interface profiles and I apply them to my leaf profile, and this leaf profile 201, 202, these are my 2 nodes identified here as blocks, 201 and 202, and I'm just adding the FIA and FIB interface profiles into this leaf profile, and that basically pretty much establishes the ether channel. So if I go to inventory here, I'll just show you one of the leaf nodes. So here's one of the leaf nodes. This is on FIAB. You'll see that it's up and that it's channeling. And here's the AEP that was applied, FIB. Same thing for FIA. Here's the FIA AEP, and it's basically channeling. As I mentioned, the Internet Edge Firewall, I'm not going to go too deep on that, but I did create a separate AEP for that firewall that is being used to peer with the fabric as well as peer with the DMZ. So in order to make our design function as or traffic policy, for example, in order for it to work as we designed, I need this firewall to kind of be in the picture. So that's kind of where it ties into the ACI fabric, and it communicates with NSX through the DMZ, as well as it injects a default route into the ACI fabric, which the ACI fabric later forwards down into the NSX layer. So what I also created was a tenant. It's called Nsx Demo. And first thing I want to kind of jump into here is show that layer 3 connectivity. So I have an Nsx Demo layer 3 out. This layer 3 out is configured with BGP. It's referencing that external routed domain, the Nsx Demo L3 domain, which has the FIA, FIB, as well as the ASA, because they're all going to be communicating on the same layer 3 out. I have my node profile here, so basically specifying node 201 and 202. Because I'm routing over VPC, I have my 2 different router IDs for each respective node, and then my BGP peer connectivity. So here you will see this is the actual ASA, and the 3 and 19 are the 2 edge gateways connecting on FIA, FIB. Moving down the line, my logical interface profiles, right? I have my ASA. ASA is connecting on VLAN 3398. And I have my NSX Edge 01 and Edge 02. So Edge 01, if you remember, VLAN 300. Here's the IP addressing for the fabric for leaf node A, or leaf node 201 and leaf node 202. And for NSX Edge 2, I'm using VLAN 301, and again, the ACI fabric is .17 and .18, and NSX there is .19. Just kind of show you that connectivity here. So under node 201 sees the neighborship up. They're all established. And so, for example, here's this is ACI node 201 communicating with Edge 01. It's established. It's using the its own internal VLAN as an update source, but it's actually using the interface of the ACI switch. So, with respect to what routes we're receiving, so here are all the BGP routes for this layer 3 out, and you're going to notice that the VXLAN networks, so we have the here's the .5, which is the logical switch, the transit logical switch. You're going to notice the corporate, you're going to notice the application tier logical switch, and the database logical switch. All of these networks are being advertised from NSX into Cisco ACI. So you're going to notice, for example, the transit logical switch here. We have a multipath setup between Edge 01 and Edge 02. And then here's the VTEP IP address to the other leaf switch, because this is from a node 201 perspective. So routing is basically working as it needs to be. To support the design further, right, we mentioned about the DMZ. So if any traffic, if any user device is connected through the ACI core, if they need to get into the DMZ. The route is right here, the 10.255.1.0 for where that VIP is. The best path obviously is through the NSX edge gateways and not through the upstream 10.2.52.55.1 firewall. Right? So the policy that we put into place, we can show here that traffic is going to flow into the NSX, through the NSX edges for the DMZ if you're connecting in through the core. So this is the layer 3 out connectivity for peering with the edges and the northbound ASA firewall. What we also configured was obviously a VRF NSX-DC-core. We have, actually let's set it to forced. That's for testing. So that NSX VRF, you know, we're actually configuring that layer 3 out based referencing that layer 3 VRF. So this layer 3 instance is with running within that VRF. Right? Moving along, I also created some bridge domains, one for the DMZ. This is just a layer 2 bridge domain, meaning ACI is acting as a layer 2 fabric. There's no unicast. There's no unicast routing here enabled. So we're basically flooding all traffic. NSX management, similar design, because what I'm doing here to make things easier, which probably won't be an accurate representation in the production network, I'm extending the management VLAN from the actual traditional network into ACI. So I'm just doing an EPG extension where my NSX controllers, my vCenter, everything that NSX needs from a management standpoint sits here, right? But in a production network, you would configure a layer 3 capable VLAN, right? So you would tie in layer 3 functionalities to this bridge domain. You would define the subnet here, but for the reasons of the demo, I chose to do an EPG extension. But my VXLAN transport, okay, is configured for unicast routing, and my default gateways are configured. So for VXLAN transport, I have the default gateway here, 254.1, and I'm also using .2 as the querier IP. I wanted to kind of separate that out because I'm doing IGMP snooping, and obviously we need to enable IGMP querier. For vMotion, configuring the default gateway, right, the 10.252.52.1. This is pretty much what the vMotion within vSphere requires. I have my application profile, so I configured an application network profile for Nsx Demo. The EPGs are kind of similar to the bridge domains. We have my EPG for the DMZ. This DMZ obviously references the bridge domain Nsx DMZ, right? So it's a kind of like a one-to-one pairing. That is the same thing for NSX management, transport, and vMotion EPGs. They're just tied to the respective bridge domains. So what we're doing here, for example, on the NSX DMZ, I added my ASA cluster as well as the fabric interconnects for the domains. And what I'm doing is I'm statically binding the cluster VLAN, ASA cluster VLAN 3397, along with the fabric interconnects coming in on VLAN 120, and I'm kind of binding them all together so they could be all in the same common subnet. And this is how we're allowing the ASA to peer with VLAN 120, which is the DMZ NSX Edge Gateway. You would notice here that I see the IP, or actually because this is acting as a layer 2 fabric, I see the MAC addresses from both the ASA and the Edge Gateway. Okay. For management, similar, right? I'm using ACI as a layer 2 fabric. So I'm binding my 6500 that I'm using as where the actual 172.30.32 network resides, and I'm just doing an EPG extension. I'm also bringing in FIA and FIB in a similar way. And here are my VLANs that I'm binding together so they can be all in the same common subnet. A little bit different with VXLAN and vMotion. So VXLAN, we only have the fabric interconnects, and we only have the, we're binding only the two FIA. So basically we're binding them to the EPG, so the endpoint group NSX VXLAN transport represents VLAN 200 within UCS, right? That's the goal here. And you would notice that on the operational state, we have all my VTEPs here for each of the ESX hosts. Once more traffic is passed through the network, through ACI, for example, it's going to learn the other IP addresses of the other VTEPs. And lastly, for vMotion, same thing, right? So we're binding the two FIA and FIB into EPG NSX vMotion, and we're bringing in VLAN 110 from the UCS domain. So they're all, both of them represent the NSX-vMotion EPG. The other thing I want to kind of note is that when I define these EPGs, okay, off the bat, I'm getting security between them all, right? So we can't just plug in, we can't just create another EPG and let's call it a server EPG, and that is bound to some other bridge domain with a default gateway. That particular EPG is not going to have any access to vMotion, VXLAN, NSX, management, etc., without a contract, right? So off the bat, by default, I am securing my NSX, all the NSX infrastructure VLANs that are required from the network in order for NSX to operate, right? So by default, I'm providing that security. Now, if I needed, for example, my external network to communicate with the VXLAN transport, right, or the VXLAN transport to communicate with the external network, then I would have to configure all the necessary contracts. So, for example, for VXLAN transport, I could create a contract with my layer 3 out. So my layer 3 out here being the Nsx Demo. I have an external EPG classification, which is just a quad 0 route. So I would specify that right here, and then I would just create a contract in between them. And that contract would basically say I'm either permitting everything, or I'm permitting something, right? But in this particular case, you probably permit everything. So I'm just going to cancel that out here. And if you want to get more granular of what networks you could actually, what networks VXLAN transport would have access to. But again, this is just a use case. This is just an example here. I would go back to my external routed network connection here, and under the networks, where I actually specify my external EPGs, I would specify that here. So that contract, if I was to create that contract right now, it would basically allow any networks that coming in from the NSX demo layer 3 out here, it would be allowed to that VXLAN transport EPG. If I wanted to get more granular, I would have to specify them here and then create those contracts as necessary. If we needed to extend NSX VXLAN transport between data centers, then, probably what we would do is we would set up separate VXLAN networks on the other data center, and then just make sure that the VXLAN transport has communication, has the capability of routing between the ACI fabrics across data centers, right? And we would make sure that the proper contracts are in place to make that happen. So this is pretty much it, what we need to be able to support the NSX architecture that we put together. There's no additional magic. Obviously, if there's going to be some external to NSX components within ACI that need to communicate with ACI, then we would have to configure those application profiles, application EPGs, and then set up contracts with those devices, right? And that would be more specifically contracts between the external routed networks. So again, I would create more specific external EPGs that are coming in from the NSX network, and I would create a contract between these EPGs and whatever else is inside the ACI fabric. For example, a database server running on a bare metal server that needs communication with, you know, application tiers on an application logical switch, application servers that are running on an application logical switch within NSX. So I would configure those contracts, and that communication will go through the NSX Edge gateways. There are also obviously other features that NSX provides for bridging, right? Extending the NSX connectivity into an external network. So, for example, ACI here, we would leverage NSX's bridging capabilities. So that can be another way to connect to external resources, assuming that, let's say, they're on a different, they're on the same subnet, right? So we could leverage NSX bridging into ACI to get that communication, that same subnet communication. So other than that, that pretty much wraps up the configuration for ACI to support this NSX architecture. So I think, I hope that this was actually informative, and I thank you for watching.